So this is our last video of first semester of Calc 2. It's pretty exciting. We're going to look at trig functions again. Integrating trig functions, we're going to focus on secant and tangent today. And the reason we look at secant and tangent together is because 1 plus the tangent squared of x equals the secant squared of x. And that's one of your Pythagorean identities from trig. So let's just try one. Let's try the tangent to the fifth of 2x times secant squared of 2x dx. And before we do any of this, let's remember the derivative of tangent. If I take the derivative of tangent, I get secant squared, right? And if I take the derivative of secant, I get secant of x times tangent of x. So after what we talked about last class, I think maybe since this is odd, I would change that. Let's see what happens if I change that. I get tangent of 2x times tangent to the fourth of 2x, times secant squared of 2x dx. And if I go up here, tangent squared is equal to secant squared minus 1. So tangent to the fourth would be equal to secant squared, or to the fourth, minus 1. So I'm going to just make this tangent of 2x times 1 minus, nope, not 1. How about secant to the fourth of 2x minus 1 times secant squared of 2x. Make it into two different parts here. I'm going to have the tangent of 2x times secant to the sixth of 2x minus the tangent of 2x secant squared of 2x. And then what can I do? Well, that works. If I let u equal tangent, I get secant squared, so that doesn't really work. It works in this one, but it doesn't work on that one. So could I rewrite this as the tangent of 2x times the secant of 2x times secant to the fifth of 2x minus the tangent of 2x secant squared of 2x. And I'm going to integrate this one separately. So if I can do this one right now, if I let u equal the tangent of 2x, the derivative of that would be 2 secant squared of 2x. So that gets rid of that, so I have minus 1/2 the integral of u du there. And on this one, notice that I made this secant here. So I have tangent times secant. I'm going to let u equal secant of 2x, this secant of 2x. So then the derivative of that would be 2 times the tangent of 2x times the secant of 2x. So it would take care of all this here. And I would just be integrating u to the fifth du. Oh, 1/2. And so I end up with 1/2 u to the sixth over 6 minus u squared over 2. And u, for this one, is different. So I get 1/2, this u was secant of 2x, times the secant to the sixth of 2x over 6 minus tangent squared of 2x over 2 plus c, and you can simplify your fractions if you want, but that will be your answer. All right, let's look at another one. Okay, let's integrate secant to the, what power do I have here? Sixth of 3x dx. I always went with the odd rule, with one of them was odd, and I think we talked about if you only have an even. I would say if secant is even, I'd probably convert it to a tangent. Let's see what happens here. Okay, so what did I do here? I was talking about converting it to a tangent, and now I have this on the screen. What you would get, I'm going to erase this. If I would convert this to a tangent, I would rewrite this as secant squared of 3x times secant to the fourth of 3x. And then you have to remember that 1 plus tangent squared is secant squared. And so there's a little algebra trick here. I'm going to just leave this one as secant squared of 3x. But this one I'm going to rewrite as 1 plus tangent squared of 3x squared. Because you have to remember the fourth power means squared of a square. So I'm squaring the square. And now I have to do lots of algebra with this. I'm going to FOIL what's inside my parentheses. And I get 1 plus 2 tangent squared of 3x plus 4 tangent to the fourth of 3x. Remember that 3x is an angle, so it doesn't change. And then I'm going to rewrite these as secant squared of 3x plus 2 times secant squared of 3x tangent squared of 3x plus 4 secant squared of 3x times tangent to the fourth of 3x. And the reason that this works out perfectly is because this one integrates secant squared. Look at your sheet, it's just tangent of 3x. These ones on this side, you can let u equal tangent of 3x. So that means du is 3 secant squared of 3x. So you basically integrate these separately, and these secant squareds are going to go away. So I'd have plus 2/3 u, what do I have there? Is that tangent squared? U squared. Oh, I still need to integrate that. Plus 2/3 u squared plus, if I let u equal tangent of 3x here, du is going to be 3 secant squared again of 3x. So plus 4/3 times integral of u to the fourth. And then we will just integrate that. So I get tangent of 3x plus 2/9 tangent cubed of 3x plus 4/15 tangent to the fifth of 3x plus c. That's it. Have a great... Okay, so before I just said that's it, but where the heck did I get this 4? There's no 4 here. Just cross off this 4. Just remember that Mrs. Elgert is not always on her A game. I don't know why I put a 4 there. There's no 4 when you... I was thinking of the power of the 4 and I put a 4 coefficient. Hopefully you caught that before the end of this video. Alright, now it's officially over.